So right now I'll be giving you a brief hardware demo of the PLC and the conveyor belt, just to see, so you guys can see how it works in a real life example. So a PLC, it's this block right here. It stands for Programmable Logic Controller. It's essentially like a small computer that controls all of the things on an assembly line or a car plant line, for example. Now, you wire inputs into the top and outputs from the bottom, and that's how it's connected to the push buttons, the motor, the speaker, the proximity switches on this conveyor belt. But when you wire these, you want to make sure you know the address for each of these inputs and outputs. In this case, there's a cheat sheet right here, but another way to check that is to look on your PLC to see where the input is wired. You'll notice a 0.01 all the way through to 7. Each of these are individual input bits. When you have a wire coming into, let's say, 0.2, and it's the first push button, then you know that when you press the first push button, input 0.2 is going to get a 1 signal going in. Depending on the logic of your program, you're going to have a certain output bit activated, which is going to be from this address. So if you activate 0.1, you'll know it's 0.1 on here, and you can wire that to the motor if that's what you want. You have to make sure you know you give your inputs and outputs meaningful tags so they make sense to you when you're programming. Keeping them as 0.1 or just the default tag 1, 2, 3 titles can get confusing, so make sure you rename those tags before you get too deep into your working out your logic. So to give a brief demo of the conveyor belt that I've already programmed, when I press the first button, it's going to activate the conveyor belt. The simulated car is going to get to the first station, which it will know with the proximity switch. That it's going to wait there for 2 seconds for assembly. Then it's going to move on to proximity switch 2, where if it doesn't pass the quality test, it goes back to the proximity or to station 1, waits 2 seconds and tries again. It's going to keep going through that loop until I press switch 2, which lets it know it's past quality. Then it goes past the third proximity switch, which increments a counter. When the counter reaches 3, it's going to stop the conveyor belt and make a noise to signal completion of that logic. So there we go. Press the first button, the conveyor starts moving. It's going to stop at the first station, and it's going to keep on jumping between these two until I press switch 2, and it goes past that into your third increment counter. If you look on the screen, you can watch that increment counter right there. You can see a 1. I'll pass another car through, and you'll notice when this jumps to 2. So waiting 2 seconds, pass quality, then that flash shows you it's gone to 2. Now when it goes to 3, it's going to activate the right hand side of that counter, which turns on the LED and signals the conveyor to both stop and the speaker to sound. So going through the first station, second station, third station activates that. That was the noise, and it stops the conveyor belt. So that was a short demo of a very simplistic car line, for example. You can get much more complicated with this. As long as you understand each block and you take each station as its own network when you're programming, it can be very simple, and you just need to, when you add those networks together, you can increase complexity and you can get much more interesting projects done. Thanks.